All right, for example 3, it says you are looking up at a flag that's 25 meters away from you at a 40-degree angle of elevation. To the nearest meter, what is the height of the flagpole and the distance between you and the top of the flagpole, y? So here we're right here, and we're looking up at a flag that's 25 meters away. So I'm going to make our ground distance 25 meters, and then we have a flagpole. And then we have an angle of elevation of 40 degrees. So again, angle of elevation, angle of depression are actually the same angle because they are alternate interior. And you can always put that angle horizontal to your right angle. So I'm going to go horizontal, and that angle is going to be like over here in this corner. So we got 40 degrees. I want to know the height of the flagpole, which is my x, and then eventually the distance between you and the top of the flagpole, which is y. So let's focus on one at a time. They're giving us this angle over here, which means my x is going to be my opposite. This 25 they gave us is our adjacent. So if we think about SOHCAHTOA, if I have opposite and adjacent, O and A, that goes with the O and the A here, which means I start with tan. So my first is going to be tan of my angle, so tan of 40, equals my O, my opposite, which is x, over my adjacent, which is 25. Again, we're going to multiply by that denominator to get x by itself. So multiply by 25, multiply by 25 over here. Then I have 25 tan of 40 equals x. And then this I could just enter into my calculator. So 25 tan of 40, 25 tan of 40. And that gives us just about 21. So x equals 21. So 21 meters. So x is 21. Then what I can do is I could do the same exact thing for my y value. So for my y value, now this is my hypotenuse. And I always like using what's given to me. This way, like just in case I messed up something with my x, I'm not messing up automatically with my y. So if I have a and h now, a and h go with c for cosine. So I could do cosine of my angle, which is still 40, equals my A, my adjacent, which is 25, over my H, which is Y. So now we're still going to multiply by my denominator. So I'm going to multiply by Y now. Multiply by Y. So I get Y cos of 40 equals 25. I need Y by itself, so I'm going to divide out by cos 40. Divide by cos 40. So that cancels, and then I'm left with whatever 25 divided by cos 40 is. So let's see. 25 divided by cos 40 is 32.6 about. So 32.6 degrees. Or not degrees. Oh my goodness. Not a degree. Here, I'm going to fix the 32. So 32.6 meters since it's the side length. For part B, Kyra is standing 50 feet from the kite she is flying. The string of the kite forms an angle of 27 degrees with the ground. How high in the air is the kite? So Kyra is over here. She's standing 50 feet from the kite she is flying. The string of the kite forms an angle of 27. So picture she's holding it. So this is the string. So 27 degrees. How high in the air is the kite? So I want to know the height here. So again, if this is our angle, then across from that angle, we got our opposite. Right next to it, we got our adjacent. So if I have O and A, again, for SOHCAHTOA over here, O and A go with tan. So I'm going to do tan of my angle, 27, equals my O over my A. So I'm going to multiply by my denominator, multiply by 50, multiply by 50. Then I have 50 tan of 27 equals x. And we enter that into our calculator. 50 tan of 27 and we get 25.5. So 25.5, and then we have feet equals our x. Part C, from the top of a vertical cliff 40 meters high, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? All right, so from the top of a vertical cliff, 40 meters high. So I have a cliff that's 40 meters, and then we're at like the top of this cliff. The angle of depression of an object that is level with the base is 34 degrees. So, again, like our angle of depression is going to be horizontal, so that's going to be 40 degrees. And then how far is an object from the base of the cliff? So if this is my base, then this is going to be our x. So we got, let's see. This is our angle. We got across from our angle, which is going to be our opposite. X is right next to that angle, so it's going to be adjacent. So again, if we deal with SOHCAHTOA over here, we got O and A. O and A go with T for tan. So I get tangent of my angle, which is 40, equals my opposite, which is 40, over my adjacent, which is X, multiplied by my denominator. So we get X tan of 40 equals 40. Divide by tan 40. Divide by tan 40. And then we get X equals 40 divided by tan 40. 40 divided by tan 40 is 47.7. So 47.7 meters. All right, sorry, let's start that again. So a zip line starts 25 feet off the ground. So I was drawing it a little bit off. So this is your zip line. It's 25 feet off the ground, has an angle of elevation of 27. So again, if this is your right angle, we're going to go horizontal to that. So that's going to be 27 degrees. What is the horizontal distance the zip line will cover? So horizontal distance is right there. So for this one, again, this is our angle. So we're going to go opposite of our angle. X is right next to it, so that's adjacent. So again, with SOHCAHTOA, we got opposite adjacent. So that's going to be tangent of 27 equals our opposite, which is 25, over our adjacent, which is X. Multiply by that denominator. So we're going to multiply by X on both sides. And then I have X tan 27 equals 25. Divide by tan 27. Divide by tan 27. And then we get X equals 25 divided by tan 27. Which is 49. So 49.1-ish. And then feet.